Thank you for the occasion. This is my first presentation at this conference, and the organizing a nice place so that everyone enjoying the discussion. And my name is Dayak from Toshiba Data Solutions. And I'm also the member of the Smart SE, a part of Smart SE member teams. And today I will introduce the current situation in the FMI and SSP utilization of the activity in Japan. So that because I am a member of the many study groups, and one is the JANDI, Japan Automotive Model-Based Engine Center. And second is we have in Japan we have FMI working groups, I will just. And three is the same topics with the data of FMI, the partial issues topics. We have a partial issue study in Japan, so that we this time I introduce the every activity. So the common issue in deep performance planning is we need some collaborative model-based development between OEM and suppliers. So that traditionally, yes, model-based design is utilized, but it's isolated with every company. So that basically is OEM need to collect the final result and the test with the test vehicle. But we are aiming for the new way. So the idea is that we have some virtual space for the collaboration. They are sharing a vehicle simulation model with each other, so that we can collaborate, discussing everything in the virtual. That is one. In that point of view, yes, this is some basic ideas for the collaborative model-based development. In the very traditional way is that we are just handing out, exchanging the model or the requirements to them with each party. So that is the traditional way. But we can extending with the current IT technologies. One idea is to we are collecting every model of the data in one place now, and we creating some database. We are calling the model share in Japan, so that every party can be registered and use the model and data. The second approach is some IT approach. Is we can connect the systems with crossover the network and connecting the different simulation system in each party with some idea to couple those. Some extended idea is a full digital integration. Every box is made in some same virtual space. But this is the solution. But the important thing is that we need some interoperability. It's important. Yes, each type is, yes, you can select each type in the so for example, the prototyping phase, maybe this type is very good, but in a detailed design phase, maybe some other types. Okay. But any types, the model and data should be interoperability. So that and again cross-step IVP and the Japan JANDI is now collaboration and making some study with together. This is, and also basically we are using the SSP and the FMI standard in this context. And inside of the Japan, we have three groups to the promoting or the studies in the FMI and SSP standard. The one is the JANDI. And the second is, again, the FMI working groups in JSA. And the third is some study groups of the virtual field. This three group is also the partnerships making and the collaboration with the study. Yes, this is some brief introduction about in the JSA FMI study groups. And we are now currently 16 companies with gathering in this. And some Mazda, Honda, or then some Denso size also member, and also some Japanese offices also have to vendor design to this groups. And the main result of this study group that we are publishing the guidebook of the FMI. And the contents is the base contents is we are chapter 2 is the FMI basics, something like basic introduction. And also we have assigned some guide, defined some guide. For example, which mode you need to select in independent use cases. And also the chapter 4 is a collection of some FAQ over here. And also the collecting some appendix is unfortunately every FM2 cannot be described, but our member of the working group will editing each portion. But this is some collections of the very basic introduction of how to utilize the FMI in the group. That is very good. Yes, and now we are FMI 3 is has coming so that we are version up this document and this year's. And unfortunately, this is I put in the D, but the English version that we are now starting translation so that we will soon to deliver to you. So that please utilize this guidebook. And please give me a comment. Yes, we can. And the second group is a virtual issue study groups. This is now participants member is 26 companies coming from the OEM supplier, and also the IT engineering companies, and also some major tool vendors will also enter to those groups. And now we have 4 major activities. One is some AI, how to create AI-related software. That is the one, some interest topic. And from the context of the collaboration with FMI, I am leading some study of the latest FMI standard. That is the one. And also the third team, ESDAM collaboration teams, is interesting about the FCP protocol for the debugging and monitor calibration of these views. And this is also the related to the FMI standard. And recently, the sports people is a very new people, but now the SSP or some OTA topics is coming, so that in some virtualization or some hyperthread in the ECU is becoming popular. So, but we are interested about how to simulate such kind of the new architecture of the ECU is interesting. So that we are just launching for students. Okay, the last one is the jumping. This is the biggest group. And now 187 companies is joining. So maybe all of the Japanese OEM and supplier and some Indian company, to vendors, component provider is joining in this group. And we have several working groups, working practice groups is constituted. And from the context of the FMI SSP portions, I will explain later, but the plant model guideline teams and model exchange process guideline teams, and also the last team, the supplier teams of these teams, these teams are handling the FMI and SSP. And the basic idea of the Jambies is first we create some common generic vehicle simulation model. And the Jambi is publishing the several types of the generic vision model. And also, second is some providing some guideline of the plant modeling. And the first simulation model is compliant with this guideline model. This is some showcase of some example of the guideline. And the third is tightly collaborating the smart SC, but we also define the process guideline for the model expansion. And about the generic vehicle model, we have a model impact guideline at first, so that we create the several types of the guideline compliant vehicle model. That means, for example, hybrid vehicle or electric vehicle, conventional engine vehicle, this kind of the generic vehicle models we are developing. And this model is basically created supporting from the OEM. For example, the parallel hybrid vehicles is originally coming from the Toyota Prius. And Nissan is also contributing to developing the EV model. So that's many parameters is coming from component parameters coming from the OEM. For example, this is a hybrid parallel hybrid vehicle simulation to construction. And the point is that we are creating a set of the open license. This is open at the I maybe describe the URL, but you can download everyone. It's pretty nice. And basically every model is originally created from using Simulink. And also we are providing the manual, complete manual about the contents. The simulation model is it's divided into the components such as ECU, engine, motor, battery, transmission, something like that. Yeah. This is the collections of the basic key components of the vehicle. And this component level is the common with the other generic model. And also the component characters can be modified using the parameter. And we are now experimenting in converting our generic simulation model into the FMI style. And now this work is now continuing, but we are, for example, that hybrid vehicle cases, this can be converted in the 2021 FMUs. And also we are verified the simulation result with the both. And basically that is work there. But we can find some issue. Is depending on the tool, so that maybe I can report to the FMI consortium to this kind of model. And the SSP portions is we are having an original manual, so that we are trying to edge some metadata from the manual and convert in the SSP. That is the currently ongoing works. So at the moment. The MIC4 is defined in the common metadata set defined with the process quantity, but we can find some maybe automotive specific metadata extensions. So find that kind of the flexibility is allowed in the SSP format. Yes. And again, the basic Japanese motivation is model exchanging is reusable of the model. So that's they how to touch the model component from the model database is a main interesting point. So that's we are the Jambi inside of the Jambi. We have some prototype. Engineering systems for the model creation and researching and review. The basic idea is that some model registration can be made in we are defining some Excel sheet for the design base specification, and also some model, FMI or simulated model can be implemented and attached to the document metadata with SSP format and stored in a database. And the user side is that they can search the necessary model components by utilizing the search key or the attached in the SSP files, and they exit the necessary model, and they evaluate it, and it connecting together and making the question. That is some basic necessary features for engineering systems of the model exchange. And we are in that conference, we are continuing the several additional workings to the how to establish a model searching is a good way. So that in this case, the main topics are method for the search key. And second is some kind of the portion can be automatized. So that we are jointly developing some automatic to converting the different topic. And also that we are starting about the traceability of the total system development with the creating simulation process standard studied in a process. This is some idea of the automatic conversion. We are defining some Excel sheet side interface sheet or the design sheet of the model. This specification can be converted in some template of the MATLAB. So and also the MATLAB, if you put in some comment in the MATLAB simulated model, that portion can be converted in an Excel sheet or the design sheet. Okay. This year we are starting some creating some use case to demonstrating our ideas. So that now we are correcting the summer management for simulation topics because we are creating some guideline or some standard template for the summer simulation system module. So that we are now creating the new demonstrations or utilizing the FMI and SSP to showing every process. And the other studies, maybe this is the same essence the topics. We also evaluating the new features layout standard for the FMI, especially in a virtual issue context. This is the series parallel hybrid equal, but this portion is collection of the issue, so that this can be utilized to the evaluation. So and we are now starting to utilize the FMI bus communication bus model to replacing this red pattern. And also that we are interested about the HCP protocol to connecting the virtual issue with the calibration tools. But our interesting point is that we are handling the multiple issue to debugging in a parallel. So that's we are now studying about this case. Okay, thank you. This is the last one. This is a very long vision, but we are now studying about a kind of the automotive industry topics, but new software-defined vehicle, something that coming. So that we need to this methodology or technology to extend to the cross-industry collaboration. That is a very long-term goals of the activity. Thank you.